Mr. Van Dong here with week 5, day 3 math distance learning. And we're going to be classifying triangles today, and we're going to do it different than the book. So please turn to page 915 in your book, but know that I am going to be teaching it in a slightly different and superior way. And also that I'll be modifying the directions for what to do in the independent practice section. So make sure you're paying close attention, please. We're not just doing what the book's doing. We're extending it a little bit because you're smart and you can handle it. All right. Yesterday we talked about how we can classify triangles in two ways. We classify them based on the size of the angles inside them, and we classify them based on the number of sides and angles that are congruent. So there's 6 special words you're going to learn today, and actually none of them are new. So I'm going to remind you of 6 special words that you've learned since 3rd grade. But in any case, a lot of us have forgotten them, and it's always good practice to work on these. We talked on Monday about how humans love to classify things, and that's where we're at right now. So we've got polygons, and polygons with 3 sides are triangles, and now triangles that have certain sized angles get a special word, and that have a certain number of sides and angles that are congruent get a special word. So let's go with that now. So everything is based on 90-degree angles here when we're looking at triangles. A 90-degree angle is also known as a square angle or a right angle. Looks like that. Why is it called a square angle? Because if you can see that it's like half a square with my arms right now. So and we make that symbol to show a right angle when we're sketching a picture too. So if it has a 90-degree angle, it's called a right triangle. It's called a right triangle. Mr. Van Dong, what if it has 2 right angles? Try to draw a triangle with 2 right angles. Do it right now. Pause the video, do it. You're unpaused. Good. You can't do that. It's not possible, right? As soon as you draw a second right angle, you can no longer connect it with 3 straight lines, so it won't be a triangle anymore. So it's just has one 90-degree angle. Boom. Now it is a right triangle. Now, if any of the angles, and it would only be, again, a maximum of 1, if any of the angles are larger than 90 degrees, it's an obtuse triangle. Now, any amount of turn that's greater than 90 degrees is called an obtuse angle. So it works really nicely. If you can remember that, say it also applies to just this angle of my arms right now is an obtuse angle because the amount of turn is more than 90 degrees. And a triangle formed, if I had another arm to connect the up here with down here, then that would be an obtuse triangle because it contains a obtuse angle. Well, Mr. Van Dong, what if it has 2 obtuse angles? Again, you can't draw 2 obtuse angles in a polygon and connect them with 3 lines. You need at least 4 lines. So you'd have quadrilateral. That's why it just has any one. If it has an obtuse angle, it's an obtuse triangle. If it has a right angle, it's a right triangle. Now, if all of its angles are less than 90 degrees, those are called. If it's less than 90 degrees, the word is it's an acute angle. Oh, it's such a cute little angle. That's how we remember acute is little. Obtuse, usually I remember, it's so obtuse. Obtuse just sounds like it's big. So in any case, it's acute. One word, acute. An acute, if a triangle has all acute angles, it's an acute triangle. So again, I'm emphasizing all of them have to be acute for it to be an acute triangle, because in every right and obtuse triangle, there are also 2 acute angles. Okay, if you look at, if you sketch the, I'm not going to try to make it with my arm. If you sketch any triangle, it's gonna 2 of them at least will always be acute, and so it's that 3rd angle that matters. Okay. So the first word that comes out of our mouth when we're told to classify triangle. Oh, that's a thing I should mention. Kids always go, classify triangle. What do you mean classify? When we get to the test and I tear my hair out and throw it out the window. That's not true, but they do always ask. There's always some kids that are like, I don't remember what's classify. I've never seen the word classify before. Classify is just the mathematical and scientific word for tell me its name. We're saying say the most specific name that you can for a shape. Because if it says classify triangles and you write it's a polygon because every triangle is a polygon, you're wrong. You're right that the triangle is a polygon, but when we say classify, we mean give the most specific name that you can. And we have to be able to give every triangle 2 specific words that go along with it based on the size of its angles and the number of sides and angles that are congruent in that triangle. Okay, so every triangle is either going to be acute, right, or obtuse. And this is what you saw yesterday. There are times where all of the sides and angles are congruent. There are times when 2 of the sides and angles are congruent, and there are times when none of the sides and angles are congruent. And it's always sides, like if you measure 2 sides, if 2 of the sides of the triangle are exactly congruent, then it will have 2 congruent angles as well. And you get to really do fun things with manipulating that information in middle school and high school as you're playing with geometry, all cool rules that are really frozen. Yeah, well, anyway. I wonder if I move too much. If I move a lot, does it freeze it? Nope, it doesn't. Okay, well, it was worth a shot. If it's got all 3 sides and angles congruent, it is called an equilateral. Equilateral triangle. Equal, lateral. Lateral means sides. So if all 3 sides and angles are the same length, it's an equilateral triangle. And spoiler alert, every equilateral triangle is acute. You can't draw an equilateral triangle any other way than with 3 acute angles. You can try if you want to, but you won't be able to do it. So that's kind of cool. Every equilateral triangle is an acute equilateral triangle. You can just say equilateral and it would be fine. But if you say acute, that's cool too, because it shows that you understand that. This is kind of the strangest word, isosceles. An isosceles triangle has 2 congruent sides and angles. I remember that isosceles goes with the 2 because it has lots of double letters in it. Like my capital I and my lowercase l look the same. And there's like 2 E's and there's 3 S's. Don't look at the S's, but there's these repeating things that make me remember that that's the one where there's 2 congruent sides and angles. Equal all of them. Isosceles, lots of those repeating letters, 2 congruent sides and angles. And if there are none, it's scaling. How do I remember it's scaling? Because it's the 3rd one, and I have tricks for these others too, and I remember that the other one must be scaling. That's how I remember it. So every triangle gets 2 words. And this is what's different from your book. Your book is like, classify the triangles only based on their angles, and then classify them only based on their sides. And that's not real life. Like usually we give both. So you can have an acute isosceles triangle. You can have a right scaling triangle. You can have an obtuse isosceles triangle. All of these words combine, except you can never have anything other than acute. Equilateral is always going to be acute. So if I was going to sketch that for you really quickly, they can combine like this. Scaling can be any of these. Isosceles can be any of these. But equilateral is always just acute. So it's really hard to see that. Don't worry about it. Those combinations of words describe the triangle. So let's actually apply this now. Let's try it. Looking at example 1, people go on a road trip. Good for them. And then their path led them in 3 straight lines. Now, planes don't actually fly in straight lines, but we're just not going to worry about it. Okay. So they've got a triangle there that is made up of every distance is a different distance, right? 924 miles, 573 miles, 729 miles. So according to classifying it by its sides, does it have all of the sides of the triangle equal, 2 of them equal, or all of them different? They're all different, right? So that's a scaling triangle. So one word is scaling. But in addition to that, because I'm telling you to, look at the angles. Are any of the angles of this triangle greater than 90 degrees? Are any of them exactly 90 degrees, or are they all acute? And at a glance, some kids are going to go, oh, it's got a right angle in it. When you're checking for obtuse and right angles, twist your book so that there's a flat line that is like perfectly like the horizon, like parallel, like a totally flat line. When you do that, then sketch what a right angle would look like. So if I sketch on this what I think a right angle would actually look like and then show it to you, that would be a right angle, straight up like that. Okay, well then this angle is larger than that. It keeps going. Or you can bust out your protractor and measure it. That's fine too. But you don't have to get the exact measurement to be able to say whether it's acute or obtuse. So that's an obtuse triangle. So the total name, the final classification of this triangle is obtuse scalene, because it has an angle that's greater than 90 degrees and none of these sides or angles are congruent. Turn the page. Mr. Van Dyke, you skipped the key concept. I know, this is our version of the key concept. It's better. Example 2. Triangles form the sides of the Khafre pyramid in Egypt. Determine the number of acute, obtuse right angles. They ignore their directions. Classify this triangle. Classify this triangle. At a glance, when I quickly glance at it, it appears that maybe all of its sides are congruent. But eyes can be deceiving, so I'm going to get out my ruler. I'm just going to double check. That bottom one is, I had it backwards, like 4.7 centimeters, and the side one is only 4. So again, sometimes changing the angle can help to see whether or not all of the sides are congruent or not. So this has 2 congruent sides. This side is congruent to this side, and then that bottom side is not congruent. Now, as a note, if I was taking notes on this, I would put a hash mark, 1 hash mark in each of those to remind me that anything that has 1 hash mark is congruent to anything else in the shape with 1 hash mark. Okay, you don't have to do that, but it can be a useful note-taking tool. So this guy down here, he doesn't get 1 hash mark. He gets 2 hash marks because he's different. So that's letting me know these are the same length. These are congruent, and this one is a different length. All right? So if it's got 2 sides and angles that are congruent, it's isosceles. Now, look at the angles. This angle is very clearly less than 90 degrees, very clearly less than 90 degrees. And when I glance up at this one really quickly, if I think I know for sure, you better turn your book sideways and really make that flat line. Think about what would a right angle look. Okay, it is, but it's less than maybe you thought. It is less than 90 degrees, but only by a little bit. So if all of the sides are less than 90, it's acute. So that pyramid is an acute isosceles triangle. Acute isosceles triangle. I want you to pause the video in a moment and classify these 2 triangles using our system, not using theirs. Don't follow their directions. I want full classification on 1 and 2, giving me the special word for its angles and its number of congruent sides and angles, okay? Pause the video now. Okay, let's see how you did. That first one has 2 congruent sides. So the special word is going to be isosceles for its number of congruent sides and angles. And then this angle, when I turn it sideways here, this angle right here, that's way more than 90. So it's obtuse. So this is an obtuse isosceles triangle. Next, okay. This one is kind of close. If you measure these, maybe you used a measurement tool. They're all different lengths, which I can show using my note-taking method. That this has 1 hash mark, 2 hash marks, and 3. So none of them have the same number of hash marks. They're all different lengths. So the fancy word is going to be scaling. And then if I take a look at every measurement, this angle right here is really close to 90. it's really close to 90. But if I look very carefully, it is less than 90. So it's acute. So that's an acute scaling triangle there. All right. On the independent practice page, for numbers 3 through 8, classify them fully. Give me the special word for the size of its angle and the number of congruent sides that it has on every single one. So there's 2 fancy words for every single triangle, okay? So you might need to measure some of these. You don't have to measure them if you can just tell, like, oh, those are all the same, or oh, those are definitely different. But if it's close, use a measuring tool. Down here, you can follow their directions for drawing the triangles based on what they say. But anytime, like on this one, it says classify it based on its angles. Classify the whole thing, Anytime it asks you to classify, I want you to classify fully based on angles and the number of congruent sides and angles. Get it, got it, good. See you guys later.